All right, let's talk about something real. As a data pro, you get handed these huge business problems, right? But the clues, they're scattered everywhere, hidden in all this messy, mismatched data. We're going to see how picking the right data structure isn't just some techie detail. It's actually the secret to finding the right answer and finding it way, way faster.
So imagine this. The business comes to you with a critical question, but the clues are all over the place. Some of your data is in a perfect, neat little table. Some of it's tangled up in code, and the rest is just, well, it's just plain text. This isn't some textbook exercise. This is what it's really like. So, where on earth do you even begin?
Okay, here's a look at what we're up against. On the one hand, you've got your structured data, clean rows and columns, totally predictable. And on the other, you have the messy stuff, semi-structured JSON coming from app logs, and totally unstructured, free text from customer reviews. Sure, they're more flexible, but man, they are a lot more complex to figure out. And yet, all three of them hold clues to the exact same problem. To make this all feel a bit more real, let's put on our detective hats. Our client is a food delivery app called Hungry Now, and they've got a serious problem. Customers are leaving, and nobody knows why. Our mission is to dig into the data, follow the clues, and crack the case of customer churn.
Every good investigation starts with the facts, right? So our first stop is the most obvious place, the company's order history. This is all stored as structured data, and it's going to give us our baseline.
So what exactly is structured data? Well, think of it as information that fits perfectly into a predefined model, like a spreadsheet or a SQL database. You've got your neat rows, your neat columns. Everything has its place. It's clean.
And here it is, the Hungry Now orders table. Because this data is so clean and organized, we can easily run simple SQL queries to find our key performance indicators, our KPIs. We can calculate things like the average delivery time or pinpoint exactly when late deliveries are happening. This data gives us the what, the basic facts of the situation.
But there's always a catch, isn't there? This type of database, which we often call an OLTP system, is really, really good at one thing: writing and updating transactions quickly and accurately. It is not built for the kind of deep, broad analysis we need to do. Trying to run complex queries across millions of rows can be incredibly slow. So for solving our mystery, it's just not the right tool for the job.
Okay, so the facts told us what is happening. Some deliveries are late, but they don't tell us how customers are actually reacting to that. To understand their behavior, we need to follow their clicks inside the app. And that leads us to our second clue, semi-structured data.
Semi-structured data is kind of a happy medium. It doesn't have to fit into a super strict table, but it's not complete chaos either. It uses tags or keys to create a kind of hierarchy. You'll see this all the time with JSON, which is perfect for capturing complex events, like a user's journey through an app. And here is a perfect example from a Hungry Now app log. This little JSON object, it captures one absolutely critical event: checkout canceled. This is a huge clue. It's a specific user behavior that was completely invisible in our structured order data, and it is a massive flashing red light for customer frustration.
Okay, so we've got the what from our structured data and the how from our semi-structured data. Now we need the final and maybe the most important piece of the puzzle, the why. Why did that person cancel their checkout? To find out, we have to turn to our third clue, unstructured data.
This is data in its rawest form. We're talking free text reviews, support emails, social media comments. It has absolutely no predefined structure, which, yeah, makes it challenging to analyze. But it is also incredibly rich, with real human context. And boom, there it is, the smoking gun, a direct quote from a customer review. This isn't just a rating of 1 out of 5. This is the story behind that number. It gives us the emotion, the specific pain points, the crucial context. The food was cold, and the app itself failed them when they needed it most. That's the why. This is where it all connects. Using techniques like natural language processing, we can scan thousands of these reviews to pull out key themes like cold food or app crash. And then we can link these themes directly to the
checkout_canceled events in our JSON logs, and the late deliveries in our SQL tables. It all starts to form a single picture.
So, we've gathered all our clues. We've got the facts, the behaviors, and the motives. Now it's time to bring it all together. See, a great data detective doesn't just find the clues. They know how to present the case efficiently and convincingly. And this is where smart database design becomes our superpower.
So, just to recap our detective process, we started with the facts from SQL. We parsed the behavioral logs in JSON. We extracted the why from the customer text. And now, we're at the final step, combining and accelerating it all for rapid analysis. Now, to do this, we need to move away from that transactional OLTP database and into an analytical database, or an OLAP system. These often use something called a columnar storage format. So instead of storing data row by row, they store it column by column. This little change makes scanning and adding up the huge amounts of data needed for analysis incredibly fast. Let's just put a number on this. Let's say our first attempt to build a dashboard combining all this data took this long to run, 12.4 seconds. In the world of analytics, that is an eternity. Nobody is going to use a dashboard that's this slow, especially not when things are busy.
So what's the fix? Well, one really powerful technique is called a materialized view. You can think of it like this. We're telling the database to pre-calculate the results of our heaviest queries and just store them as a ready-made answer. So instead of doing all that hard work every single time, it just looks up the answer we prepared earlier.
And the result? It is stunning. By making that one design change, the query time plummets from 12.4 seconds all the way down to just 0.6 seconds. That's a 95% improvement. All of a sudden, our analysis isn't just possible, it's interactive. We've made our insights accessible to everyone.
And, it's not just about speed, it's about being smarter, being more accurate. By combining features from all three data structures, the delivery times, the checkout cancellations, and the review sentiment, we can build a much more powerful model to predict which customers are likely to leave. Here, you can see the model's accuracy, its AUC score, jump from 0.71 to 0.79. That is a massive improvement that can save the business real money. So we cracked the case, but for many of you, the next step is just as important, proving you did it. So how do you take all this amazing detective work and turn it into powerful, tangible evidence for your portfolio or for your endpoint assessment?
You want to frame your accomplishments with really clear I statements that showcase your skills. You can now confidently say things like, I identified structured, semi-structured, and unstructured sources. I parsed JSON logs to link behavior to orders. And here are the really powerful ones. I created materialized views to improve performance. And I demonstrated a measurable improvement in both efficiency and accuracy. This is exactly what assessors want to see. So the big takeaway is this. Every single dataset, no matter how messy it looks, contains a story. And by understanding these different data structures and applying smart design, you're not just organizing data, you're uncovering the truth. So the only question left is, what story is hidden in your messiest data?